Let me ask you something. When I say the word computer, what pops into your head? You're probably picturing your laptop, maybe the phone in your hand. But you know, that one little word covers this incredible spectrum of machines, and each one is built for a wildly different purpose. So let's peel back the layers and really understand the four fundamental types of computers that make our modern world tick. To get us started, here's a little thought experiment for you. On one hand, you've got the massive, super complex prediction of global weather patterns, and on the other, just a simple text message to a friend. I mean, they seem like they're from completely different planets, right? And boom, there it is. They're both powered by computers. But, and this is the key, the machine that predicts a hurricane is a whole world away from the one that sends your favorite emoji. It's all about different jobs needing different tools. And that's the core idea we're going to break down today. Okay, first up, we're starting with the absolute titans of the computing world, supercomputers. And look, these aren't just fast. Their speed is honestly mind-boggling. They're built to focus all of that incredible power on one single, massive task at a time. The phrase you really got to latch onto here is single, complex, computational problem. A supercomputer isn't for browsing the web or checking your email. No way. It's a highly tuned specialist designed to do one thing: solve one enormous problem as fast as humanly and mechanically possible.
So it's all about raw, brute force calculation speed. The best way to think of it is like a super powerful telescope, but instead of looking at stars, it's peering into massive data sets. It's the kind of machine used for simulating the birth of entire galaxies, or predicting weather with pinpoint accuracy, or, cracking the most complex codes imaginable. It's a puzzle solver for the biggest puzzles we have.
All right, so we've met the sprinters of the computing world. Now it's time to meet the marathon runners. These are the quiet, unsung heroes of our daily lives, the mainframe computers. Because if supercomputers are built for pure speed, mainframes, they're built for endurance and just unwavering reliability. And yeah, the definition really says it all. The focus shifts entirely from speed to high-volume, reliable transaction processing. This is a machine that's engineered from the ground up for one thing: to never, ever fail, even when it's juggling millions and millions of tiny tasks all at once. Its whole reason for being is to act as the digital backbone for huge organizations. Just think about your bank for a second. Every single tap, every swipe, every transfer, no matter how small, has to be processed instantly and perfectly. That's the mainframe's job. It handles this constant flood of transactions from all over the world without ever dropping the ball. They are truly the invisible engines of global commerce. So let's just put them side by side to make it crystal clear. The supercomputer's goal is calculation speed. Think simulating the entire life cycle of a star. The mainframe's goal is transaction reliability. Think processing 1 million credit card swipes in an hour. One deep, incredibly complex task versus millions of simple but absolutely critical ones. Two giants, two totally different missions.
Okay, now we're going to shift gears in a big way. We're moving from the giant, industrial scale down to the individual. This is where the real revolution kicked off, the arrival of the personal computer. This is the machine that brought all that computing power out of the data center and put it right on our desktops.
The magic words here are general purpose and individual use. Unlike the hyper-specialized machines we've been talking about, the PC was a true jack-of-all-trades. It was your typewriter, your calculator, your artist's canvas, your gaming console, all of it rolled into one box. And you just can't overstate the impact. It was revolutionary. The PC didn't just change how we work, it completely reshaped our world. It took computing out of this corporate fortress and brought it into our homes. And in doing so, it unleashed this massive wave of creativity and forever changed how we learn, communicate, and live our lives.
And that brings us right up to today, to our final and, let's be honest, our most familiar category. We took all the power of that personal computer and we found a way to shrink it down to fit right in our pockets. We're talking, of course, about the mobile device, the computer that is with us, quite literally, 24/7. And the two words that define this era are portability and constant connectivity. This isn't just a tiny PC. It's a completely different kind of device, one that was born to be on the move, to be always on, always connected to the world's information, and more importantly, to each other.
You know, in so many ways, this is the culmination of everything we've talked about. It's a general-purpose machine, just like the PC, but it's also packed with sensors that make it aware of its surroundings. It's the computer that knows where you are and what you're doing, and in all likelihood, it's the very device you're using to watch this right now.
So, let's just pull it all together for a quick recap. We went from the warehouse-sized supercomputer, built for raw calculation, to the room-sized mainframe, all about reliability, down to the desk-sized personal computer for general, everyday use, and finally to the pocket-sized mobile device designed for constant connectivity. 4 types, 4 completely different scales, and 4 totally distinct missions.
This incredible journey from a machine the size of a warehouse down to one that fits in our pocket, that's pretty much the story of the digital age so far. But, that story's far from over. So it leaves us with a really interesting question. If these 4 categories defined our past and our present, what new frontiers, things like quantum or biological computing, are going to shape our future?